Hi there, Mr. Sutton here, bringing you the IM3 Honors Chapter 3 Quiz Extra Practice on Complex Numbers.
To simplify this radical with a negative inside, we first have to take out that negative as an I, because I is really the square root of negative 1, so you're basically factoring this into radical negative 1 times radical 48, so that's where the I is coming from. And then we have to simplify the 48 as well. The biggest perfect square that goes into 48 is 16. 16 times 3. And then the square root of 16 is 4. 4 times 8i is 32i. So then final simplified answer would be 32i radical 3. To find this very high power of I, we need to figure out where we are in the cycle of 4 with the number 107. So if I divide 107 by 4, that gives me a remainder of 3. And that tells me that I to the 107 is really equivalent to I to the third. And I to the third is negative I. To simplify I to the 62, we need to figure out where in the cycle of 4 62 is. So if I divide 62 by 4, I get a remainder of 2. And that tells me that this is really equivalent to I to the second power, I squared. And I squared is negative 1. To subtract these complex numbers, we basically have to get rid of the parentheses by distributing and then combine like terms. So this first parentheses, we have an invisible positive 1 being multiplied by it. So really it's just 2 minus 7i with no change, just drop the parentheses. For this next one though, this minus parentheses really means negative 1 times all the stuff in here. So we have to distribute that negative 1 first. That's going to be negative 5 and then minus 7i. And now we combine like terms. 2 minus 5 is going to give us negative 3. And then negative 7i minus another 7i is going to be negative 14i. To simplify this expression, before I can add anything, I need to simplify all these powers of I to either some version of 1 or I. So to see that, I have to figure out where in the cycle of 4 I am. I do that by dividing each of those exponents by 4 and looking at my remainder. 88 divided by 4. Well, 4 goes evenly into 88, so that's a remainder of 0. That means I can rewrite that first term as 2i to the 0. For this next one, 22 divided by 4 gives a remainder of 2. So this is really 4i squared. And then 55 divided by 4, that's going to be a remainder of 3, because 4 goes into 52 evenly. So this is going to be 5i to the third. Now I'll simplify each of these just a little bit more. I to the 0 is really 1, so 2 times 1 is just 2. I to the second power is negative 1, so 4 times negative 1 gives me a minus 4 here. And then finally, I to the third is negative I, so this can be reduced to negative 5i. Combining like terms, 2 minus 4 gives me negative 2, and we still have that negative 5i that we can't combine with anything else. On this problem, to multiply these complex numbers, we just need to distribute and then simplify any I squareds. So negative 5i times 4 gives us negative 20i. Negative 5i times 7i, that's going to be negative 35i squared. And then I squared is really negative 1. So this is really negative 20i plus 35 then, because you have negative 35 times negative 1. Or we could write this as 35 minus 20i, because we like to write the real numbers first. To multiply these complex numbers together, I'm going to start by foiling them. So we have 4 times the second parentheses. That's 4 times 2, giving me 8. And 4 times negative 8i, which is negative 32i. Next, we do negative 2i times the second parentheses. So negative 2i times 2, that's negative 4i. And then negative 2i times negative 8i gives us positive 16i squared. So this 8 in the beginning is going to stay where it is for now. Negative 32i minus 4i is negative 36i. And then 16i squared, well, I squared is really negative 1, so I can write this as negative 16. And I can combine that negative 16 with the positive 8 out in front, so that's going to be negative 8 minus 36i. To multiply these radicals together, I have to start like I would with any radical that had a negative inside, and take the negative out as an I. So our first radical I can rewrite as negative 5i radical 6, and then we'll be multiplying that by 2i radical 3. Now that I've done that, let me multiply the outsides and insides separately. So on the outside, I have negative 5i times 2i, giving me negative 10i squared. On the inside, 6 times 3 is 18, so we have the square root of 18. Negative 10 times I squared, well, I squared is really negative 1, so that's positive 10 outside there. And then 18, I can split that up into 9 and 2 square rooted. Square root of 9 is 3. 3 times 10 is 30. So this is 30 radical 2. To simplify this problem, I need to get rid of the I in the denominator. To do that, I'll multiply by I over I, which is really just 1. So in the numerator, I have negative 10i. In the denominator, negative 3i squared. And now I just have to simplify this power of I down here. I squared is really negative 1. Negative 3 times negative 1 gives me a positive 3 down there. And there's nothing else I need to change. To simplify this one, I need to get rid of the I in the denominator. So I'm going to do that by multiplying by I over I. In the numerator, distributing, we have 3i plus 2i squared. And down below, we have 2i squared. Now I'm going to simplify those I squareds to be negative 1s. So up top, we can write, this will be a negative 2 now, negative 2 plus 3i. And then downstairs, we've got just negative 2. To simplify this fraction, I need to get the I out of the denominator. The only way to do that is by multiplying by the conjugate of the denominator, which is going to be the same terms but with the opposite sign for the I. So instead of 1 minus 5i, I'm going to multiply by 1 plus 5i over itself. And I have to do top and bottom because I'm really just multiplying by 1 here, which doesn't change the value of anything. All right, so let me distribute in the numerator. 6i times 1 is still 6i. 6i times 5i is going to give me plus 30i squared. And in the denominator, I have basically 1 minus a times 1 plus, or a minus b times a plus b. It's that situation where the answer is always a squared minus b squared. So squaring the 1, I get another 1. And 5i, if I square that, that's going to be 25i squared, and I'm subtracting that. At this point, I still need to turn those I squareds into negative 1s. So in the numerator, this now becomes a negative 30 plus 6i. In the denominator, this is going to be a negative 25 times a negative 1, so plus 25. And 1 plus 25 is 26. And we're not done yet because these are all even, so I can reduce everything here by 2. So in the numerator, I could write this as negative 15 plus 3i, and down here, this is going to now become a 13. And this is as good as it gets.